Intrusive igneous rocks form when magma consolidates beneath the surface of the earth. A pluton is a rock body composed of intrusive igneous rock. The term may be used for bodies of all sizes, from those a few meters long to those that are exposed over hundreds of square kilometers. A structural study of plutons involves a consideration of their internal structure, shape and size, as well as the structural and chronological relations to the adjacent rocks. The rocks in plutons may range from fine grain to very coarse grain. The grain size is related to the size of the pluton, the cooling history, the volatiles present during consolidation, and the crystallizing power of the various minerals species. Plutonic rocks are coarse grained igneous rocks in which the grains range in size from 5 mm to 3 cm. Many are equigranular with all the grains essentially the same size. Others are porphyritic with a phenocrust from 1 to 10 centimeters long. Pegmatites are very coarse rock in which the grains exceed a diameter of 3 centimeters. The coarse grains result from the presence of volatiles during the crystallization. Many plutonic rocks are massive, showing no preferred orientation of the constituent minerals. Others are characterized by foliation resulting from the parallel arrangement of platy or ellipsoidal mineral grains. Primary foliation forms during the flowage of partially crystallized magma. Secondary foliation forms in an already consolidated rocks. Layered rocks are those that consist of alternating sheets of different composition. The layers may range from fraction of a centimeters to several meters in thickness. If the platy minerals in layered rocks are parallel to one another, the rock is foliated as well as layered. Igneous intrusions can be of variety of shape, size and ranging from huge batholiths to bodies only 1 or 2 meters across. The general term Pluton can be applied to any of these. The intrusions may cut across the bedding of the country rock. They are then termed discordant, or we can call them it is transgressive. The example is Dikes and Laccoliths are some of the good examples of discordant ore bodies. Intrusions that follow the bedding of the country rock, such as sills, are termed as concordant. A contact is said to be concordant if it is parallel to the bedding or foliation. If it cut across the bedding or foliation, it is said to be discordant. Intrusions are liquefied rocks that form under Earth's surface. The magma found under the Earth's surface is slowly pushed up into Earth's surface in which any cracks or spaces it finds. And this process that takes the millions of years. When the rock cools down slowly, the magma got crystallized into minerals. The best examples are Sierra Nevada in California, where large granite formations occur. The best examples of an intrusion is Devil's Tower. One is the important is that sills. Sills, sometimes called sheets or tabular plutons, that are parallel to the bedding or schistosity of the adjacent rocks. The rocks in the sill is younger than the rock on the either side of the sills and are horizontal, or they may be vertical, or it may be inclined. Sills are relatively thin compared to their extent, parallel to the structure of the adjacent rocks. Sills range in size from tiny sheets less than a centimeter thick and large bodies many hundreds of meters. The smaller sills can usually be traced for only a few meters, but the larger sills cover thousands of square kilometers. A simple sill results from a single injection of magma. It is chilled only at the margins. A multiple sill results from 2 or more injections of the same kind of magma. A multiple sill, although possessing chilled margins, also possesses a medial zone of finer grained rock, the position of which depends upon the relative thickness of the individual sills. The greater the number of separate injections comprising the multiple sills, the greater will be the number of chilled zones. If the injections followed one another in relatively rapid succession, the chilled zones may be obscure. A composite sill results from two or more injections of magma of different composition. Example, a sill formed by separate injection of diorite and granite. A small offshoots of the granite cuts the diorite, indicating that the granite is younger than the diorite. Differentiated sill are of particular interest because of their bearing on the problem of magmatic differentiation. Such sills are generally hundreds of meters thick, and they are initiated by the injection of horizontal sheet of magma. The magma cools slowly and under the influence of gravity separates into layers of different composition. As crystallization proceeds, any mineral that are heavier than the magma tend to sink, whereas the crystals lighter than the magma tend to rise. To distinguish a differentiated sill from a composite sill may be difficult. 1. A sill in which the lighter rocks are at the bottom cannot be due to differentiation in place under the influence of gravity. Number 2. Differentiation in place is implied if the various layers are gradational into one another. Number 3. Although the sharp contacts seem to imply successive injections, the liquid resulting from differentiation in place may move several scores of feet and produce a sharp contacts. The differentiated sill to be deformed in a later orogenic episode and even to assume a vertical or overturned attitude. Lava flows as well as sills are tabular bodies of igneous rock that are parallel to the bedding of the overlying and underlying formations. It is essential, therefore, to establish a criteria to distinguish the sill and lava flows. These criteria are based primarily on the fact that sills are younger than the rocks above and below, whereas lava flows, although younger than the underlying rocks, are older than those above. A sill is characterized by a relatively smooth, fine grained top in which the vesicles, that is nothing but the gas bubbles, are rare. In particular, the overlying rocks may be penetrated by apophysis of the sill, and they may occur as inclusions in the sill. A lava flow has a rolling vesicular top. The fragments of lava may occur in the overlying rocks. Lava flows are likely to be cut by irregular dikes of sedimentary or pyroclastic material, representing the debris washed into cracks in the lava. Laccoliths. Laccolith is an intrusive body that has domed up strata into which it has been inserted. Laccoliths, composed mostly of diorite porphyry, are 3 to 6 km in diameter and usually a few thousands meters thick at maximum. It is apparent that all transitions may exist between laccoliths and sills. In a typical laccolith, the diameter is only a few times greater than the thickness. In a typical sill, the diameter is many times the thickness. The body may be termed a laccolith if the ratio of the diameter to the thickness is less than 10. Most laccoliths, especially in the western United States, are found in regions where the sedimentary rocks are essentially horizontal except around the laccoliths. Bismoliths. A bismolith is a body of which the roof was uplifted along a circular or arcuate fault. Such intrusions have been described from the Black Hills of South Dakota, and some of the bodies in the Henry Mountains are bismoliths. Some bodies may combine a features of both laccoliths and bismoliths. The Skaergård intrusion in Greenland is remarkable for the layering it displays both on the scale of hundreds of thousands of meters. The rocks are chiefly various kinds of gabbro composed of plagioclase, pyroxene and olivine. The layering, which is inferred to have been originally nearly horizontal, is due to differential settling of minerals under the influence of gravity. Because the contacts converge downward, it has been assumed that the body is shaped like an inverted cone. Whether the laccolith or sill develops when magma spreads along horizontal bedding planes depends upon several factors. The most important is the viscosity of the magma. Low viscosity will cause thin widespread intrusions such as sills. High viscosity, because it prevents lateral spreading of the magma, causes laccoliths. The roof of the laccolith is lifted by the hydrostatic pressure of the magma. The overlying sedimentary rocks composed by the force of the magma, the elongated parallel to the bedding planes. The amount of elongation depends upon the shape of laccoliths. The thickness of the overlying sedimentary rocks is reduced. Tension cracks may form because of this stretching of the roof. Laccoliths are broken by radiating and concentric cracks. This is partly because of the roof rocks have generally been destroyed by erosion. Lopoliths. Lopoliths has been defined as a large concordant intrusion in a structural basin. It is essentially a sill, but differs in that it is very large and it is associated with a basin lopoliths. Lopoliths are arcate or circular. The type example is the Duluth Lopolith in Minnesota, is a great arcade body nearly 250 kilometers long and 30 kilometers wide. A large sheet or lens dipping southeasterly on the northwest flanks of the Lake Superior basin. It is as much as 8 kilometers thick. Two major units have been distinguished in this area, the Duluth Gabbro complex and the granophyres, that is red rock. The Duluth Gabbro complex consists of multiple intrusions, which although the average composition is gabbro. It shows a notable differences in the percentage of the minerals. The rocks consist chiefly of olivine, plagioclase, pyroxene and some potash feldspars. The Bushveld igneous complex is one of the most spectacular igneous bodies in the world. The curve system is younger than the emplacement of the Bushveld complex and rests on unconformably on all other rocks. The intrusive body is essentially a used composite lopoliths composed in turn of two major units. The upper lopolith is composed of granite. The lower lopolith consists of great galaxy of rocks called norite. This unit actually consists of layered mafic and ultramafic rocks including norite, pyroxenite, horsbergite, gabbro, anorthosite, olivine, diorite and granodiorite. There are also layers of chromitite, magnetite and platinum. The great diversity of rocks is due to successive intrusions and the gravitational settling of minerals. Each of the two lopoliths is several kilometers thick. At Sudbury, Ontario, a large intrusions with associated nickel ores has been interpreted as lopoliths. Phacoliths. Phacoliths are concordant intrusions confined to the crest of anticlines or to the trough of synclines. Phacoliths are not only crescentric in cross section, but also in plane because they are commonly associated with plunging folds. The thickness of phacolith is measured in hundreds of several thousands of meters. One of the important discordant intrusion is dikes. Dikes are tabular bodies of igneous rock that cut across the structure of the older formations. Tabular bodies of intrusive rocks cutting massive structure, such rocks are also called dikes. Most dikes are formed by the injection of magma into a fracture. The walls may be pushed apart by the pressure exerted by the intruding magma, or the magma may quietly well up into fractures opened by tensional forces. The terms simple, multiple, composite and differentiated may be applied to dikes in the same sense that they are used in sills. Simple dike is a result of a single intrusion of magma. Multiple dike is the result of two or more intrusions of same kinds of magma. Composite dike is the product of the intrusion of two or more kinds of magma. Differentiated dike is one that was intruded as a homogeneous magma, but from which the two or more varieties of rocks have formed in situ. Dikes may be very small, and dikes a fraction of a centimeters wide and few centimeters long may be associated with larger igneous bodies. Most dikes are 1 to 5 meters wide. The distance from which a dike may be followed depends upon the nature of the exposures. Example, in Iceland, the dikes are 10 kilometers to 30 kilometers long. In England, the Cleveland dike is around 150 kilometers long. The Medford dike near Boston is 150 meters wide in places. A dike set consists of parallel dikes. Where the dikes are very abundant, the term dike may be applied in some areas, several sets of to be present, and each set may be characterized by its own peculiar petrography, indicating that the various sets of different ages. The fractures such as joints or faults that greatly antedate the intrusion. Radiating dikes are found around volcanic centers. The dikes around the Spanish peaks in Colorado are a good example. 300 dikes have been identified in its area. The thickness ranges from 1 meters to 30 meters. The individual dikes may be followed for many kilometers, and in places the dikes stand up as walls. The original fractures now filled by the dikes are tensional in origin. The magma in the central stocks exerted an outward pressure to produce extension fractures. Ring dikes. Ring dikes are oval or arcuate in plan. The contacts are steep, either vertical or very steep. The average diameter of ring dikes is 8 kilometers, but some have diameter of only 350 meters. The average width of ring dikes is 1000 meters. Downfaulted volcanics are found inside some ring dikes. They were erupted during the same igneous cycle as the ring dikes. The classic area for ring dike is the tertiary volcanic district of Scotland. Some other areas are New Hampshire, Norway, Nigeria and Australia. The origin of the ring dike, if the hydrostatic pressure of the magma is less than the lithostatic pressure in the surrounding rocks, the latter will push the magma. Tension cracks would form parallel to the greatest principal stress axis and form two sets of shear fractures. These fractures that are most commonly utilized in the emplacement of ring dikes. Example, in New Hampshire, the contacts of many of the ring dikes are essentially vertical. It seems unlikely that they could have been formed in the manner outlined above. An alternate hypothesis is that the magma pushes on its roof like punch the vertical fractures forms above the reservoir. Once the overlying block is isolated by fractures, it sinks into the reservoir because it is heavier than the magma. The mechanism by which the ring dikes form is called cauldron subsidence. Surface cauldron subsidence results when the fractures extend all the way to the surface. Underground cauldron subsidence results when the subsiding blocks does not reach the surface. cone sheets. Cone sheets are dikes that belong to a concentric inward dipping system. None of the cone sheets extend all the way around the central area. The average dip is 45 degree, but the outer cone sheets tend to dip more gently than the inner. Example, Scottish cone sheets, which are tertiary in age or projected downward, they meet at a focus approximately 5 kilometers beneath the present surface. Cone sheets, typically a few meters thick, may attain a thickness of about 15 meters. In Mull, an island of the west coast of Scotland, they are concentric about two distinct centers. The cone sheets of the older center are cut by those associated with the younger centers. The origin of the cone sheet is due to the hydrostatic pressure of the magma exceeds the lithostatic pressure of the surrounding rocks. The magma will be pushing on its walls. The tension fractures will form parallel to the greatest principal stress axis, which control the emplacement of cone sheets. Apophyses and trunks or dikes, in some instances rather irregular, that obviously have been derived from nearby igneous body. Volcanic vents. Volcanic vents, also called necks and plugs of the roofs of volcanoes that have been eroded away. They are circular, subcircular, or even irregular in plan. They are few meters to kilometers in diameter. Some composite vents are even larger and have resulted from several successive eruptions. The contacts of volcanic vents with their surrounding country rocks are typically steep. They are vertical or inward dipping, rarely outward dipping, etc. Although it is usually a large, the vent at Cripple Creek, Colorado shows many of the features characteristics of vents. The contacts are discordant and the foliation of the Precambrian sheets is cut off by the material in the vent. The contacts generally slope inward. In this case, the vents is composed of several separate funnels that narrow downwards. Much of the rock in the vent is tuff and breccia. Lava is represented by rhyolites and phonolite. Medium grained intrusive rocks are represented by syenite. Precambrian rocks were blown out in series of explosions, but the voids were filled up by tuff and breccia. Magma pushing up through the breccia consolidated to form the rhyolite, phonolite and syenite. Batholiths. The term batholiths literally means the deep rock, originally based on the assumption that coarse grained igneous rocks, in contrast to volcanic rocks, dikes, sills and other small bodies, congelated at relatively a great depths. The term batholiths are used generally for bodies with the following characteristics. The rocks are plutonic, but most batholiths are composed of several lithologic and textural varieties that were emplaced at slightly different times. Number 2, the term is arbitrarily restricted to bodies occupying an area of more than 1000 square kilometers. Number 3, they commonly enlarge downwards or at least do not smaller. Number 4, there is no visible floor. Geophysical evidences indicates that many batholiths have floors, but at depths of several kilometers. The roof may be irregular, roof pendants are downward and the projections of the roof, example septa, are the parts of the roof that lie between two different intrusions forming the batholiths. Cupolas are isolated plutonic bodies that presumably connect the downward with main batholiths. Stocks. Stocks are similar to batholiths, but the surface area is arbitrarily fixed at less than 50 square kilometers. Radiogenic methods of dating have been applied very successfully in unraveling the history of batholiths. The Sierra Nevada and adjacent ranges in California 5 intrusive epochs occurred between Middle Triassic and Late Cretaceous. Each epoch lasted 10 to 15 million years and took place at intervals of about 30 million years. These intrusive epochs were associated with regional deformations. Intrusive igneous rocks form when magma consolidates beneath the surface of the earth. The most important is the viscosity of magma. Low viscosity will cause a thin widespread intrusions such as sills. High viscosity, because it prevents a lateral spreading of the magma, causes laccoliths. Lava flows as well as silts or tabular bodies of igneous rocks that are parallel to the bedding of the overlying and underlying formations. The great density of rocks is due to successive intrusions and gravitational settling of minerals. Phacoliths or concordant intrusions confined to the crest of anticlines or to the trough of the synclines. Multiple dike is the result of single intrusions of magma. The concordant intrusions like Lopoliths are the treasurer of some important economic potential of ore deposits of magnetite, chromite and platinum.